Welcome back to my channel. In this video, I will cover how to solve this block placement queries problem. Basically, it is from the contest, Leetcode contest 131 by weekly 131, which happened yesterday. And in that, I was able to solve three of them. The last one I wasn't able to solve. So in this video, I'll cover the understanding of the problem statement as well as the solutions, how to solve this one. So basically, if you read out this problem statement, it says that there exists an infinite number line with its origin 0 and extending towards the positive x-axis. Okay, and it says that we have an infinite number line with origin 0 and it is extending towards positive x-axis, positive side. Okay, the right hand side, and you have a 2D array queries which contains two types of queries. 2D array, you know that, right? Array of an array. That is 2D array which contains two types of queries. And there are two types of queries. First type of query says that query of I, if it is equal to in the format of 1 comma x, then build an obstacle at a distance x from the origin. It is guaranteed that there is no obstacle at a distance x when the query is asked. So the one stands for the first query and two stands for the second query, and it doesn't signify anything more. So whenever you see this one, which means that the query of type 1, 2 means query of type 2. So what we need is what comes after this one. So we need the x from here and we need a x and a sz. I'll come to the second query next part, and in the first part it says that 1 comma x, and that x we need to use to place an obstacle at a distance 0 to x. 0 to x. Build an obstacle at a distance 0 to x, and which means that see so the distance x from the origin, like, so the positive axis is there and origin is there, and it is an infinite number line. So they have given a distance x and we need to place that obstacle at a distance x from the origin. And it doesn't they didn't say what the size of the obstacle, so it doesn't matter, so no need to assume anything on your own. So just take what they have defined it. Now I'll come to the query of type 2. It says that 2 comma x comma sz. Check if it is possible to place a block of size sz anywhere in the range 0 to x. I see. On the line such that the block entirely lies in the range 0 to x, a block cannot be placed if it intersects with any obstacles, but it may touch it. And note that you do not actually place the block, queries are separate. So it says that uh, you they have given x comma sz, so you have an option to place a block of size sz in anywhere in the range 0 to x, anywhere in the range between 0 to x. And it will be guaranteed that sz will be less than x, I think so. Let's see the uh, x comma, so it doesn't, they haven't mentioned it. So we need, if it is, just take care of the count case. If sz is greater than x, obviously we can't place the block. And while placing the block between 0 to x, we need to make sure that whether any whether any obstacles is hindering to that block. It can touch the obstacle, but it cannot overlap with the obstacle. And they are also saying that not, you do not actually place a block, queries are separate. So which means that if a query of type 2 comes like this, one query of type 2, 2 comma 0 comma 2 comma 2 comma 1, and there is another query which again comes like 2 comma 2 comma 1. So it doesn't matter that you have already placed the block, so you can place the block on top of it. So that's what they are saying. You are not actually placing the block, you are just checking whether the block can be placed or not. So that's what we need to see here. And just give the whether if the block can be placed, then true. If it cannot be placed, then false. And it doesn't guarantee that query 1 will be coming once and then after that it will be followed by query 2s. So it can be anything. So it can start with query 1, query 2, and again query 1 can also come. So we need to keep on updating the obstacles in the x-axis and keep on checking the blocks which comes after it, whether it is not overlapping with the obstacles or not. So in this problem, basically you can solve it with o of n cube brute force solution, but in order to optimize it, you need to use a segment tree concept. So you can read the segment tree concept to the CP algorithm blogs, or just a very big blog. Just read how to update the queries and lazy propagations and all. But if you need some video solution, then you can refer the Take You Forward YouTube channel. They have made a 2 to 3 videos. Just these 2 videos is enough. Segment tree, how to build it, and lazy propagation. I'll attach the link of the segmentary take you for a channel in my description. So basically, in order to get into this solution part, so I'll just briefly go through you how what is the segmentary, why it is used, and how it is created in a quick in detail. You can read through the CP blog or watch the video of the take you forward. So basically, let's say you have an array, and array says like this, and 8 2 5 1 4 5 3 9 6 10, and array indices are starts with 0, and you're also having a query which ranges from L to R. L can be anything where L is less than R, and let's say we need to find maximum in the range L to R, queries like that. So if it is a single query or a double query, or if the query is single, or if there are 10 queries, then you can actually run through the for loop and get the maximum in the range L to R. But if it is little bit higher, you can still use the prefix sum method, and the complexity will be often. But if the query is coming out the range 10 power 5, but and the array size is also in the more range 10 power 7, then obviously you can't solve it. You need to use the segmentary concept. So basically, how we will use segmentary is, and let's say we have a node which describes the answer from 0 to 9, 0 to n, and there are 10 nodes, and we are dividing this parent node into two child nodes based on the formula 0 plus, I mean, what, let's say this is L and R. L plus R divided by 2. 0 plus 9 divided by 2 will come around 4, and so for integer value, not the float value. So we will take the left child to the 0 to 4, and the right child will be now 4 plus 1 to n. And similarly, we will be keep on breaking it until it reaches the last value. 0 to 1 will be broken down into 0 to 0 and 1 to 1. And so, and 0 to 0, and how we will get the answer for this one is by getting the answer from the child nodes. So basically, once you get the let's say the problem talks about the maximum with the range L to R queries. So 0 to 0 maximum will be 8. Let me just try to do it. And 0 to 0 maximum will be 8, and 1 to 1 maximum will be 2, and 0 to 1 maximum will be max of 8 comma 2, which is 8. And what is this thing, 2 to 2, right? This is already in the single integer, so this maximum is a single element, which is 5, and the max of 0 to 2 will be max of 8 comma 5, which is again 8. And similarly, go on, and you will reach the top, and you can get the value. So if you have a doubt how many nodes will be having in the total segment tree, that will be around 4n, where n is the size of the array, and the proof of that is there in this Quora blog, and I'll attach this link as well in the description section. You can go through it. So now let's that's why we are using segment tree. And you will be have a question, what is the use of the segment tree, what is the actual advantage of doing it in this way. So basically, since we're doing it in half and half, so the time complexity becomes log n for any operation, whether the updating the node, or getting the answer, or getting the answer for the 0 to n node, or 0 to, I mean, L to R node. Everything becomes a log n complexity. That's the advantage of using the segment tree. So let's get into the solution video. We can just define a class for the segment tree, and basically you can get the segment tree template from the either chat GPT or GFG. So you just need to use the template, and you modify it accordingly. If you see the segment 3 class, and they have defined n, and it will be total tree size will be n slash 4 and default value is 0. As I said, why it is n slash 4, you can go through this article here, as I will attach it in the description. So, and then just get the maximum value, the function, these are all the standard function, updating the node, and get the range value interval in the specified L to right to left, and then updating the value interval, and that's it. So basically, why how this problem is related to segmentary in the sense, like after placing the obstacle, you just need to see the whether the block, whether the block can of size is that can be play no, can be placed in the range 0 to x. So instead of going through the brute force for loop from iterating from the 0 to x, so the block is there and the distance between the subsequent blocks which comes across the for loop, instead of that, if you create a parent node with 0 to x, and you can divide whether a block can be placed in the range 0 to x by 2 and x by 2 plus 1 to x. Even, and this can be given here like this in the child node, and whatever the child node is coming, you can get the answer to the parent node, similar like that. And thanks, yeah, I'll attach this thing, the solution code also in the description. So thanks for watching this video, and don't forget to like and subscribe. Bye.